Hello Math 112 and welcome to the course. For our very first section, we want to discuss graphs and graphing utilities. And that's the name of this section. We're going to spend more time on graphs than graphing utilities. Graphing utilities is just using a calculator to graph. And this course, I don't want to focus on using a calculator to graph. I want you to be able to do this by hand and then use the computer graphing tools to graph from what you've done by hand. But let's start right at the beginning. And this dude right here is how we get started in this course. This is René Descartes. He's a French philosopher, mathematician. He was born in 1596 and he lived until 1650. And in the early 1600s, René Descartes, again, was a philosopher. I know you've heard, I think, therefore I am. But we're going to focus on the mathematics side. And he developed something that you know very well, the rectangular coordinate system. What is that? Well, it is a way to plot any location within a 2D surface. So this is your favorite XY axis. If you're not friends with the XY axis right now, I need you to go ahead and wipe that out and say, yes, we're going to be friends with the XY axis. I know that sounds cheesy, but y'all, you spend so much time graphing in this course that you got to make friends right now. So the XY axis, called the rectangular coordinate system, it doesn't have to be an X and a Y. It could be other variables, but we tend to use the XY axis the most. This thing has another name, the Cartesian coordinate system. Where does that come from? Well, René Descartes. So anytime you hear the Cartesian coordinate system, that is named after the founder, René Descartes. Now, what about this Cartesian coordinate system? It's really just two number lines, one horizontal, and we tend to call this horizontal guy right here the x-axis. Now, I mentioned a minute ago, it doesn't have to be called the x-axis. It could be a different variable, but the majority of the time we call the horizontal number line the x-axis, and then the vertical number line, not as thick, the y-axis. Okay? Now, to name a point or to find any location within this grid or this xy axis, we use something called an ordered pair. Okay, so right here, it's a pair of coordinates. The x is called a coordinate and the y is called a coordinate. So this ordered pair is made of two coordinates, an x and a y. The reason we call it an ordered pair rather than just a pair is because the order matters. The first value in this ordered pair is always going to represent the horizontal axis, and the second value in the ordered pair is always going to represent the vertical axis. So for example, if I wanted to plot the point -1, 5, then -1 is along the x-axis or the horizontal axis. Now, how does this work? Well, 0 right there in the middle, so positive is to the right. Notice it's even labeled with a scale of 1. So this is 1, 2, 3, 4, 5. That one's labeled. 6, 7, 8, 9, 10. And then the negative numbers are to the left. So -1, -2, -3, -4, -5. So you see the -1. Now I don't want to put a point there because I also have to find the y coordinate, which is 5. Now if I went ahead and said x is -1, that could be anywhere along this line. And then also y is 5. So again, positive is up, negative is down. If y is 5, right along here, okay, that would be anywhere along here. But where they intersect is actually your point. So this vertical and horizontal line you will not draw. But this is the location. So where x is -1 and y is 5, and that's your point. And I imagine you're probably pretty comfortable with this idea already, but just hold that thought. Let me tell you a little bit more about the Cartesian coordinate system. Okay, we have quadrants, and where x's are positive and y is positive, that's called quadrant 1. Where x is negative and y is positive, that's called quadrant 2. Over here in quadrant 3, x's are negative and y's are negative. And finally in quadrant 4, x's are positive and y is negative. You may even see something like this occasionally. So x is positive, y is positive. Here x is negative, y is positive. Down here they're both negative values, and over here x is positive and y is negative. Now in this particular course, Pre-Calculus Algebra, we don't spend a great deal of time using our knowledge of quadrants and the name of the quadrants, but you certainly need to know how to graph. One more thing before I switch pages on you. What is this guy right here called? That is the point 0, 0, and it's called the origin. So that point right there in the middle of our rectangular coordinate system, XY axis, Cartesian coordinate system, all those terms represent the same idea. That point right in the center, 0, 0, is called the origin. Now let's get to the meat of what we're doing here. I want you to, anytime I give you a problem, so notice this is example A. I tend to letter my examples starting with A, and I want you to pause the video and do what's asked here. I want you to plot these 5 points on your own XY axis that you're using for your notes. Either use graph paper if you like, or just draw an XY axis out. Pause the video, get the job done, and come back. If you know this is easy, then just fast forward and check your work and move on. But if you're struggling, whether it's this problem or another problem, then watch the solution as I work out the problem, and then that way you're kind of ahead of the game. And then if you still struggle after you see me do it, maybe watch another example following that example, or just contact me and say, hey, I'm stuck, or hey, did you make an error, because I'm really not understanding this the way you're presenting it. So that's the way I want you to handle this entire course. So go ahead and pause the video and then plot these points. Okay, so you're back. Did you do it right? Well, x is 1, y is 3. So I go to x is 1 and y is 3, and that's the point 1, 3, and it's called A in our problem. So you either label it 1, 3 as it is, or just put A there to represent that. Now, negative 1, 3, right here, there's my B value. C point, 1, negative 3. So I'll go over to x is 1 and y is negative 3, and I would label that my C point. D, 0, negative 5. So 0, negative 5. 0 means I don't go left or right whatsoever, and then I go down to negative 5. That's my D value. And then finally E, negative 4, negative 7. I'm having to change colors as we go through here, and I want one that I haven't used. How about orange? So negative 4 right here, but remember, don't make a point there. Always go down to or up to the y value, and there's negative 7. Just got to be very careful with these. When you do this homework online, there is no partial credit for being close. You have to be exactly right. So be careful when you plot points or graph lines. I want to point out something to you. Notice point A is in quadrant 1 right here. B is in quadrant 2. E is in quadrant 3. And C is in quadrant 4. Well, what about D? D is on the line, right? That is right there on the y-axis. What quadrant is it in? It's not in a quadrant. We call that a quadrantal point, and it has no quadrant if it's on either the x-axis or the y-axis. So hopefully plotting points went well for you. I know you've done that before. Now for example B, again, this may be something you are very familiar with. Graph the following equation. If you know how to do that, just pause me, work it out real quick, and then just fast forward to the result and make sure you got it right. But I do want to impress upon you what's really happening when you're asked to graph an equation. What you're really doing is you're trying to graph every solution. Every single solution. Well, what in the world is a solution? What is a solution to an equation? Well, when you have two variables, in this case x and y, then you're trying to find the x value and the y value that makes that equation true. So for instance, if I threw out at you, say, 0, 1, is that a solution? How would you find out? Well, you would take 0 and plug it in for x, and then you take 1 and plug it in for y, and just see if it's true. So I'm going to replace the y value with 1. I'm going to replace the x value with 0, and see if this is a true statement. So I have 1 on the left. 2 times 0 is 0 plus 1. Well, we know 0 plus 1 is 1. 1 equals 1. Yes, that's a true statement, right? So that means that yes, 0, 1 is a solution to that equation. Well, let me throw another one out at you. How about the point -1, 3? Is that a solution? How about you pause it real quick, if you've been hanging with me, and determine if that's a solution. What do you think? Okay, so what do? I take 3 and plug it in for the y value, that's on the left, equals 2, and I'm going to take -1 and plug it in for the x value and just do the math. Notice I'm not solving an equation. I'm just simplifying each side independently. So 3 on the left stays 3. 2 times -1 is -2 plus 1 is -1. I'm using order of operations. That's very important. 3 is equal to -1. That's not true, right? So -1, 3 is not a solution. Now, my next question to you before we get started on really graphing this thing is, how many solutions does this equation have? Well, we found one of them is 0, 1. Does it only have one solution? Is it just one point that makes this equation true? Are there 2 or 3? Well, in this case, there are an infinite number of points that make this true, right? So there are an infinite number of solutions, and that's what a graph is all about, trying to express all the solutions in a visual way. And that's what René Descartes figured out. Okay, so how can we do this? Well, this brings me to something called a T-table. Now, a T-table named traditionally is because it makes a T like this, and you have a column for X and a column for Y. I'm making this a little bit bigger, more like an H table, right? Because I'm putting an extra column over here for the ordered pair written together. So this is a lot of work, right? Notice I already picked values for you. You'll find that the homework does this as well. They want you to let X equal -3, -2, -1. I know you can read that. So how do we do this? Well, let's do that. First, let's start with -3. So y is equal to 2 times -3 plus 1. And that's going to give me y is equal to -6 plus 1. And that gives me -5. When I add my negative and my positive value, remember the rule there is you subtract and you keep the sign of the larger number. So -6 is not larger, but 6 is larger. So my answer is negative. So that is -5. And you just do that all the way down. So I'm going to try it for -2. So y equals 2 times -2 plus 1. That gives me -4 plus 1, which gives me -3. Now you might be wondering, can you just do this work in your head? Well, if you're good at it, of course you can just do it in your head. But if you struggle with getting these answers right, or you are calculator dependent, don't be. Write this down on paper. I cannot express enough how important it is to write all of your work down. That will help you get partial credit on problems. If you need some partial credit, say you get it wrong, but all your work is right and you just made some silly mistake, write your work down. It's also easy to find your errors if you've written your work down. Let's plug in 0. How about 2 times 0 plus 1? 2 times 0 is 0 plus 1 is 1. Are you following this? No problem, right? Can you do the rest of them in your head? Of course you can. Here, take this one. 2 times 1 is 2 plus 1 is 3. take the 2. 2 times 2 is 4 plus 1 is 5. And then 3, 2 times 3 is 6 plus 1 is 7. All of these are solutions. If I write them as an ordered pair, that's -3, -5, -2, -3, -1, -1, 0, 1, 1, 3, 2, 5, and then finally 3, 7. So again, you could possibly feel like this is overkill. Like, why is she writing that third column? Or why is she showing all this work? I think the more work you write down is the best for you and anybody grading your work. It's easier to find errors, but it really is all about your understanding of the material, and it makes all the difference. Now, what am I going to do? Well, I'm going to plot all 7, I think it is 7, of those points. So -3, -5, so my x is -3, my y is -5, right there. Do I need to label it? Probably, but what you're going to find out is when you have a ton of points plotted and you label them all, it gets really congested. So I'm going to avoid that for now. -2, -3 is right here. -1, -1. I've got 0, 1, 1, 3, 2, 5, 3, 7. Well, if you'll notice, there's definitely a pattern to what's going on here. If I connect my dots from left to right, it appears that I have something called a straight line. Now, I'm drawing arrows on each end because I feel confident, and you probably do too, that that pattern is going to continue on forever. It's not going to curve back down. Each time I plug in a larger number, I'm going to multiply it by 2 and add 1. Multiply by 2 and add 1, and that's going to stay along this line. Now, if I give you all these answers in table form, you're like, okay, I see your answers. But suddenly, when you put it on an XY axis and you see it visually or geometrically, then you go, oh, well, there's a pattern here. They all follow this straight line. So anything along this line will make this equation true, and that's what graphing lines is all about. Now, I'm going to go ahead and throw this out. I'm going to mention it again, but notice this equation. If I talk about exponents, this x variable is raised to the first power. This y variable is raised to the first power. Anytime you have an equation that the x and y are raised to the first power, there are no exponents in your problem other than the x and y raised to the first power. There are no square roots. There are no absolute values, nothing extra going on, just multiplication, division, addition, subtraction. Then you're going to have a straight line. Okay, that's called a linear equation. We'll have an entire section on that, but I wanted to go ahead and point that out. Now, many of you know that to graph a straight line, you really only need 2 points. If I only had this point right here and this point right here, I would just connect those 2 dots and I would get the same straight line. So if you know ahead of time you have a straight line, then you only need to plot 2 points. Why did I do 7? Because 7 is really probably enough, not always, but 7 gives you a good feel for what the graph is going to look like. All right, let's move on to another graph. Now, once again, I would love for you to pause the video, fill in this T table or H table as I have it for you. Go ahead and plot the points, connect the dots, and see what you get. Now, let's go ahead and talk real quick. This y is to the first power, this x is to the second power. So this does not fit that pattern of a straight line that we did just a minute ago, right? Because my x is squared. So don't expect a straight line because I'm kind of leading you in. It's not going to be one. Pause it, see what you get. All right, how did it go? If you think you've got it, fast forward to the solution. If you're really confused or you just need a little bit of hand holding right now, that's okay. So what am I doing? I'm plugging in all these points, x's over here, -3, -2, -1, 0, 1, 2, 3, into this equation. So I have y, that's what I'm looking for, equals. Now I'm plugging in -3 and squaring it and adding 1. What's up with the parentheses, right? Is that the same as -3 squared plus 1? it's not. Okay, so this is the wrong way to do it because I'm not just squaring the 3, I'm also squaring the negative. This is why I have parentheses. So negative 3 squared is negative 3 times negative 3, which is 9 plus 1, which is 10. So when you plug in negative 3, you get 10 as a result. Now I'm going to do this again. Y is equal to negative 2 squared plus 1. That gives you 4 plus 1, which is 5. I'm not digging that at all. Hold on. There we go. All right. And then negative 1 squared plus 1 is 1 plus 1, which is 2. What about 0? So y is equal to 0 squared plus 1, which is 0 plus 1, which is 1. And then y is equal to 1 squared plus 1. Now, do I need the parentheses or not? Well, it never hurts to have them around anything you substitute. That's always safe. But when we plug in a positive number, it wouldn't matter if it was there or not. So 1 plus 1 gives me 2. I did square that 1 and got 1. 2 squared plus 1 is 5 because 2 squared is 4 plus 1 is 5. 3 squared is 9 plus 1 is 10. Again, if I write these in ordered pair form, just to really send home the fact that 1 point is a coordinate. It's 2 numbers or 2 coordinates. 2, 5, finally 3, 10. Let's plot these points. Okay, so the x coordinate is negative 3 and the y coordinate is 10. Almost fell off. That's 6, 7, 8, 9, 10. It's really at the top. So there's not a line there, but we're going to put a point right there. That is negative 3, 10. Negative 2, 5 is located here. Negative 1, 2, 0, 1, 1, 2, 2, 5, and then 3, 10. Now, if I stick to connecting my dots or my points from left to right, this is what I have. Now, you're supposed to put arrows on the end if the graph continues. So if we plugged larger and larger values in, imagine what would happen. We would square that number, add 1, it would just continue up forever. Now, that arrow is not straight up. It's up and to the right. And on the left, the same thing is going to happen. Now, this shape, just so you know, it's ahead of schedule, but this is a parabola shape. Parabola shapes happen anytime you have an x squared and a y to the first. You can go ahead and expect that. There will be a point where you're supposed to memorize that fact, even on the first test, so that's why I'm throwing it out here prematurely. But you'll do enough of these where you get the hang of this. Okay? Feel all right? Good. Let's try another one. All right, it's time to pause it again. Go ahead and plug in all those values. Come back to me. See if it's right. If you're struggling, just work on it. Come back when you feel just stuck and you need some support. So what are we doing? It tells us negative 3, negative 2, negative 1, all the way to 3. So let's plug those in for our x values. Notice it's asking for the same numbers every time. If you plug those in all the time, are you going to get perfect graphs? Well, it really depends a lot on your equation. But it is a good place to start. Let me say it that way. Now, we got to be careful here. Y is equal to, there's a negative in my equation. I'm plugging in for this x squared. So remember, parentheses is especially when you have a negative in there. But I say use parentheses all the time. It's safe. Now, how do I handle that? Order of operations says I have to handle this exponent first. Do these two negatives cancel out? They do not, because you have to handle this exponent part first. So that's going to be y equals negative, and then negative 3 times negative 3 is positive 9. So this negative came from the front, and then that's 9. So that answer is negative 9. We do this again, that's going to be negative of a negative 2 squared. The same thing happens. The original negative comes down. Negative 2 squared is a positive 4, so my final answer is negative 4. So when we square negative 1, it's 1, and then throw a negative in front of it, it's negative 1. When you square 0, it's 0. Throw a negative in front of a 0, and you still have a 0. When you plug a 1 and you square it, it's 1, and then the negative thrown in there is -1. So the sign doesn't change because I'm plugging in a positive number. Let me write that down. So it's y is equal to the negative that's in your equation, and then the 1 is squared. So I handle 1 squared first, that's 1, and then this negative out front just comes down, which means this dude is -4, and that's -9. Okay, now I'm going to erase some of my work at the bottom of the page because it is in the way for this graph. If you need to see it, just rewind. All right, so -3 is my x-coordinate, -9 is my y-coordinate, and there we are. -2, -4. Oops, I didn't do that right. Which is easy to do. Okay, so watch your work. -2, -4. -1, -1. 0, 0, so I have a point on the origin, and then 1, -1, 2, -4, and 3, -9. Again, you connect dots from left to right, okay, and then the arrows have to do with the behavior of the graph for the points that you're not plotting. So if I can continue to plug in negative numbers, what's going to happen is this graph is going to keep going down, not straight down, but down at an angle to the left and down forever. And then on this other side to the right and down forever. And this is what all of our solutions look like. They follow on this line. And notice that again, that's that parabola shape. We kind of knew that was coming ahead of time because of the x squared and the y to the first. All right, for those of you who want this over with, go ahead and pause it, plot this one, get it done. For those of you who want to hang around and see the solution, here we go. So again, notice it says I'm required to use -3, -2, -1, same as the last couple of problems, for my x values. That will help me get a good looking graph. Now I've got y is equal to, I'm removing this x right here and I'm replacing it with -3. Notice it's got these two vertical bars around it. Most of you know what that is. Absolute value, right? Now an absolute value, the definition means it's a number's distance from 0. So how far is -3 away from 0? Well, it is 3 away from 0, and then we still have to subtract 2. Now, really, y'all know the rule. Absolute value means you take whatever numerical value you have inside here and make it positive. That's how you calculate distance anyway. Distance is not a negative number. It's always a positive number. And so the distance -3 is from 0 is +3. But I'm just going to make that positive, subtract 1. So that gives me y is equal to 1. And I'm going to keep doing that all the way down. So y equals the absolute value of -2. Subtract 2. Well, the absolute value of -2 is +2 minus 2, and then 2 minus 2 is 0. And then the absolute value of -1, which is going to be 1, and then minus 2. So that's +1 minus 2. 1 subtract 2 is -1. What about the absolute value of 0? How far is 0 away from 0? Well, 0. So 0 minus 2. 0 minus 2 is -2. The absolute value of 1 minus 2. Now, absolute value does not mean change the sign. It means make it positive. If it's already positive, then that answer is just whatever the value is. So 1 minus 2 is -1. The absolute value of 2 is 2 minus 2 is 0. And the absolute value of 3 is 3 minus 2 is 1. If I write these in ordered pair form, it gives me this column. And again, if you're in a hurry, you may want to skip that column, but it does drive home what we're doing. So let's plot these points. -3, -1, right here. Okay, I did that wrong because I'm not reading. Let's try that again. -3, +1. There we go. -2, 0, right there on the x-axis. -1, -1. 0, -2, 1, -1, 2, 0, and 3, 1. Well, that looks a little bit like the parabola shape we got earlier, but notice it's not curvy looking at all, right? this is a straight line on this side, and yes, it does continue in that fashion forever. And then you have a straight line on this side as well. Well, it turns out absolute value graphs, as long as your y is to the first and your x is to the first. So I don't want to say all absolute value graphs look like a V shape. All of them that have x to the first and y to the first have this V shape. And so that's something to keep an eye on. And if you know it's going to be a V shape before you even get started, then that is very helpful. All right, the last one of these I'm going to torture you with. Okay, so graph the following equation: y equals x to the third minus 2. We haven't done an x to the third problem together. Gives us the same x values to substitute in. Again, do you always have to plug these numbers in? No. Okay, this is just a good starting point. So when I plug in -3, that's going to be -3 to the third subtract 2. Well, y'all, -3 to the third is going to be -3 times -3, which is 9, times another -3, which is -27. Okay? Minus 2, which is going to give me a -29. All right, let's keep going. Y is equal to -2 to the third minus 2. Now, -2 is -2 to the third is -2 times -2, which is 4. Times another -2, which is -8, minus 2, which is going to give me -10. And then y is equal to -1 to the third minus 2. -1 to the third is -1 times -1, which is 1, times another -1, which is -1, subtract 2, which is -3. Y equals 0 to the third minus 2. Well, 0 to the third is 0 minus 2, which gives me -2. Now, these positive ones we might could do in our head. Look, 1 to the third is 1 times 1 times 1 is 1, minus 2 is -1. 2 to the third is 2 times 2 times 2, which is 8, minus 2, which is 6. 3 to the third is 27, minus 2 is 25. So that means we have the point -3, 29. Uh-oh, what do? I wrote -29. I even went the wrong way. -3, -29. It falls off my graph. Is that okay? Yeah, we can handle that. Okay, we don't have to plot that point. -2, -10, way on down here. And let me graph in red so we can see this better. So -2, -10, there we go, big point. -1, -3, right here. 0, -2, 1, -1, 2, 6, jumps up real fast, and then 325 again falls off my graph. Is that okay? It is. It really is. You know, it's way up here and then way down here. So it looks like this in the middle. Looks like it makes a straight line. Y'all, it really doesn't. If I would plug fraction values in there, it curves like that. And this comes down, and that behavior is down forever. And then this goes up, and it goes up, but not straight up forever. This little bumpy thing I have going on here is not really there. It's just a really slippery computer screen I'm working with. But that is the shape of a graph that has x to the third and y to the first and nothing else going on in it except add or subtract out here. So that is an x to the third graph. I don't want to give you the impression they all look just like that. They can vary a bit, but it's not a straight line. I do want to impress upon you that. It's not y to the first, x to the first. But the more you plot points and the more you get used to this idea, the easier all this material is going to be. So please promise me you're going to do this by hand on paper, even when you're doing the homework, and then that'll make the computer work much easier for you. Now, the remainder of this video is going to go by much faster because it takes a while to graph, but I just want to point out a few things that you're going to see in the homework and ideas that you need regarding graphing utilities in this case. So again, graphing on a calculator is not something I want you to be doing. If you're used to doing that and you want to check your work, fine, but you can't use it on the test. So I would just get used to the fact of doing this by hand. But being able to read graphs in graphing utilities is important. So I want to take a look at this first problem. It says number 29 because I got it right out of the textbook that you're using, the real one, not just a PDF file. And it gives us -5, 5, 1 by -5, 5, 1. And we're trying to match which graph here, and really it's not a graph, it's just really a coordinate axis, goes with that. Now, let me explain a little bit about what they mean by -5, 5, 1, and then by -5, 5, 1. What does that mean? Okay, these are your x coordinates, these are your y coordinates, and this last one in line, that's your scale. Okay, so that means each dot is 1 unit. And this means it's going from -5 to +5 with a scale of 1. So this is 1, 2, 3, 4, -5. Then 1, 2, 3, 4, +5. And again, these are 1 apart. That's what that means. Well, the y is exactly the same. So this is your scale. Every dot or every index is 1 unit. And it's going from -5 to 5, but that's the y value. So 1, 2, 3, 4, 5, and -1, 2, 3, 4, 5. So we're trying to find the one that matches that one. And it's certainly not going to be this one because that's not even centered. Okay, now these two look a lot alike. This has got a whole bunch of lines on the y, and we only need 5 up and 5 down. So that one's out, that one's out. Look at these two. Looks like it goes 5 to the right, 5 to the left, 5 up, 5 down. This goes 5 to the right, 5 to the left, and there's just 2 marks up and 2 marks down. So that one's not it. So the 29 is C. And that's how we're going to work all the way through this, but I'm not going to write it all down. So let's look at 30, question 30. I'm going to highlight it for you over here in pink. Yay. Now this time, it says you go from -10 to 10, but the scale is by 2. Well, if it's by 2, and I sketched this over here for you just real quick, that means that's 2, 4, 6, 8, 10, and -2, -4, -6, -8, -10. You see what we're doing here? And this scale, the y scale, is also by 2, but it only goes down to -4, so that's -2, -4, and up to +4, +2, +4. Catch that? Do we see that one? Yes, we do. So here's number 30, right here for you. Okay, you see how this works? All right, let's move on to the next one. Okay, number 31. Now, wow, look at that scale. It's by 10 on both of them. So the scale is 10. That means every time we draw a mark, okay, that it's 10. So we go -20, but by 10. So that's -10, -20. And we go to 80 to the right. So 10, 20, 30, 40, 50, 60, 70, 80. Mine ain't looking so good. There we go. Okay, now the y's go from -30 by 10, so -10, -20, -30, and then up to just +10, and that's it. Now, do we see that? I don't. Oh, to 70. My bad. I'm not looking. That's a 70, not a 10. So 10, 20, 30, 40, 50, 60, 70. Sorry, that's more like it. Do we see that? Yes, we do. There we go, right there. So that is number 31, which means by default, this one's 32, but let's check it. So our scale is 20, and we go to -40 by 20. So -20, -40 looks good there, and the right to +40, +20, +40, that looks good. But now, over here, the scale is 100, but we're going to -1000 and +1000, which means we need 10, 100, 200, 300, 400, 500, 600, 700, and you get the point all the way to 1000. So I feel convinced that this is 32. But mainly, I just want you to be able to read that notation is really just what it is, okay? Here's a good thinking question for you, or 3 of them. So how could we determine if the graph of y equals -3x plus 6 passes through the origin? What could we do to determine if it passes through the origin? And remember, what is the origin? It's the point. Come on, pen. Getting irritated. I apologize. I had to close the program and restart the whole thing. Now my pen's working again. So how could we determine if the graph passes through the origin? If you'll remember, the origin is the point 0, 0. So if 0, 0 is a solution to this equation, then we know that it passes through the origin. So you could just take 0, plug it in here, 0, plug it in here, and see if it's a solution. That's one way to handle it. There are others also. You could graph it and just look at it, or you could do a table and do it. So let's see if we can answer these questions by just completing a table. Or what if you were given a table already? So let's plug in our regulars. You want to? So how about, or maybe you don't, but let's do it anyway. So -3, -2, -1, 0, 1, 2, 3. And what am I doing? I'm plugging it into y is equal to -3 times -3 plus 6. -3 times -3 is 9 plus 6 is 15. And then y is equal to -3. This time we're plugging in -2 for x. -3 times -2 is 6 plus 6 is 12. Y is equal to -3 times -1 plus 6. Notice I'm not showing any work this time, although I think you should. -3 times -1 is 3. 3 plus 6 is 9. Y is equal to -3 times 0 plus 6. That's 0 plus 6 is 6. Y is equal to -3 out front times +1 plus 6. Forgive my writing. That's -3 plus 6 is 3. Y is equal to -3 times +2 plus 6. Hey, -3 times 2 is -6. Plus 6 is 0. Notice these numbers are gradually getting smaller, so you would think the pattern is going to continue. So -3 times 3 plus 6. -3 times -3 is times +3. I need to be really careful. That's -9 plus 6. Which is -3. Again, these numbers continue to go down, okay? I see the pattern. You could also fill this in over here, -3, 15, -2, 12. That third column is great until you get really comfortable with this, and then it's just feels like a waste of time. That's your call unless the homework asks for it. Then you have to do it. All right, so answer these questions, right? How do we know if the graph passes through the origin? Well, 0, 0 is not on this list, okay? So it does not pass through the origin because it would have to have the point 0, 0 over here, okay? Where does the graph cross the y-axis? Now let's think about that. So this is the y-axis, okay? Anything on this line has x equal to 0, doesn't it? Okay, so where along here do we have x equals 0? Well, it's this guy right here. That is where the graph crosses the y-axis at 0, 6, and that happens to be called the y-intercept. Okay, now here, where does the graph cross the x-axis? So again, here's our axis. This guy is the x-axis. Well, look, everything along this axis, the x-axis, has y equals 0. Every single point that lands on it has y equals 0. Okay, do we have a place where y is equal to 0? Well, we do. Look, right here. So this guy right here, 2, 0, is our x-intercept. Was that the easiest way to do that? Not plural. No. The easiest way to do it would be to have a graph in front of you, but I did see that there were homework problems that give you a table and ask you questions like this, so I wanted you to see that. But what if we do exactly the same question, but with a graph? Okay, does the graph pass through the origin, which is in pink? No, it doesn't, because the red line doesn't go through there. What is the x-intercept? Boom, there it is. You could label that point as 2, 0. That's the x-intercept. What is the y-intercept? There's where it crosses the y-axis right there. That's the point 0.06, and that is the y-intercept. So if you have a graph, it's pretty easy to answer that question. So this is no. This is y-axis was first, so 0.6. X-axis was second, so 2 or third, 0. All right, let's do that a whole lot more and then call this video done. So let's look at this particular graph. What is the x-intercept? What is the y-intercept? Okay, the x-intercept is right here. That's where it crosses the x-axis. So the x-intercept is at the point 50. Now there are two ways to answer these questions. You could give it in point form, which is what I prefer, but I have found the homework likes this. They just want to know the x value. So be careful. That's one of the struggles with doing homework online using publisher software is they have very specific ways they have to have these answers. And so for x-intercepts and y-intercepts, a point like this in coordinate form is appropriate and really ideal, but they tend to ask for it this way. Okay, what about the y-intercept? Where does it cross the y-axis? Right down here in red, that is the point 0, -5. So if I were to answer that question in point form, which is ideal, I think, 0, -5, but if they just want the coordinate, it is -5. It's the y value. Okay, so be careful with that. Now, very quickly, I want you to do this next problem. Pause it, answer the same two questions, and we'll move on and be done. What about this? Identify the x-intercept and the y-intercept. So the x-intercept, wait a minute, I have two of them, right? Is that okay? Well, of course it is. So this point right here is the point -20. This point right here is the point +20. If you're doing it in homework, actually, they're going to ask you to put commas between them. Likely that's what it's going to be. But don't trust me, because the homework could change any minute where they want it in point form instead. So make sure you read the directions thoroughly. Well, what about the y-intercept? Let's do that in blue. Where does it cross the y-axis? Right here, very clearly, right there. What is right there? Well, that point for the y-intercept is 0.4, not 40, right? Because the x is 0, the y is 4. And if you were to type it in the homework, last time I saw it, it would look like that. Okay, almost done. Hang in there. All right, identify the x-intercept and the y-intercepts again. So where does it cross the x-axis? Right. What's your favorite color? Let's go purple. Right here. Right? What's the y-intercept? Right here. Also, it's the point 0, is both the x and the y-intercept. If you were doing it in the homework, it would be x equals 0 for the x-intercept and y equals 0 for the y-intercept. It's the only place that it can be both the x and the y-intercept 0. And then the last one that I have in mind, right here. Here we go. What is the x-intercept? What is the y-intercept? Okay. Y'all, here's the x-axis. That circle, which is pretty cool, does not cross the x-axis whatsoever. Not at all. But it does cross, and be careful with cross, it does touch the y-axis, and that is an intercept. If there is a point on the axis, that's considered an intercept. So that is the point, if I label it in point form, 0.4. So the y-intercept right here would be y is equal to 4. What's the x-intercept? None. Not at all. Often in the homework, none is depicted with that, which is the empty set. Okay, now I'm going to come back probably with a small video. I'm not going to swear this to show you how you would do this in the homework, just an example or two in case you get stuck on how you use the graphing tools. But this pretty much covers section 1.1. I hope it went well for you, and anytime you have questions, please feel free to contact me. If you find errors, which they exist all the time. I do the best I can, but it's easy to make silly mistakes. You know this. Let me know, and I will work on fixing the videos. I hope you have a wonderful day.